Hello Creativerse. I wanted to show you guys how the implementation of the ALU works. This is gonna be divided on two videos. The first one is going to show how the decoder for the operations and the shifter works. Then it's going to show the AND, the OR, and how the shifter works. The second one is going to be focused on the add, the look-ahead carry adder that is on the ALU, and the ripple carry adder that I did here, and the comparison of how this input on the top is the output on the top is for this one on the back, and the one on the bottom is for the ALU. So okay, I'm going to get started with these ones. Let's first check these two decoders. They are actually the same. They are the 2x3 decoder because they can get a fourth operation, but I don't have it implemented because I don't need it. First, I want to talk about why use a decoder instead of something like this, because these 5 inputs, they don't use a decoder. Why do I have 2 of this and use a decoder instead of you having 3, and then let's say this one on when I have an add, this one on when I want to AND, and this one on when I want to OR. The reason for it is because if I have these 3 gates, I can potentially have them all on at the same time, and it doesn't make sense that you're going to add, AND, and OR at the same time, because you used to get one output. So what we usually do is you create the decoder, and the decoder outputs just one. In case of a 2 digits, there are 4 combinations. This one is 0, which is 0 and 0. This is 1, which is 1 and 0. This is 2, which is 0, 1, and this is 3, which is 1, 1. Those are 4 different numbers that you can do with 2 digits. So you basically create 4 different combinations and use AND gates to tie with this. I'm going to show you how this works. I'm going to show this one, and then this one right here is going to be literally just with different numbers. First, you check that this is ALU select 1 and this is ALU select 0. And I just have implemented 0 is going to be add, which is this one on the top. 1 is going to be AND, and 2 is going to be OR. So let's go on there. I'm going to put this here as a reference. Let's suppose this is select 0 and this one is select 1. So this one, what it's doing is it's just getting select 1 and it's outputting the inversion of select 1. I use naming not select 0. I mean, this is select 0, not select 0. And this one right here is doing the same thing for select 1. So we want add to be active when this is 0, 0. And when this one is 0, let's just go for true and false for this, since I have select 0 and select 1, so it doesn't get mixed. So let's say this is false and false. When both selects are false, both inverter gates are going to be true. So we want the add, which is going to be 0, to be tied to these 2 inverter gates. So it's going to be to not 0 and not 1. Not select 0 and not select 1, and you have an AND. So the only way with this is going to be true is when these both are false. So next is going to be AND. You want AND when select 0 is true and select 1 is false. So when this is true, this one's going to be false, so you don't want to tie it to this one, you want to tie it to select 0. But when this one is false, the not select 1 is going to be true. So to be able to get this combination, you're going to have to tie it to not to select 0 and to not select 1. And that's AND for you. You have select 0 and not select 1. This is 2. This is going to be OR, which since this is false, the not select 0 is going to be true and select 1 is going to be true. So you want to tie it to not select 0 and to select 1. to not select 0 to select 1. Supposing that we have another operation that we want to implement, it will be with 3. When these two are on, you will have to tie it to select 0 and to select 1. It will be something like this. And this is going to be true just when both of these switches are on, while the ones on the top. And we don't want this. And this one right here is going to work the same. It's just that they are different names. But this one is ALU S1, S for shift, and it outputs not S1. This one is going to be S0 and it's not S0. Then this one right here is 0, which is not S0 and not S0 and not S1, and it's NS. NS I made stand for not shift. This is shift left, which is 1, which is not select 0 and select 1. Actually this is 2. And this one is 1, which is shift right. You have select 0, you have select 1. So yeah, that's how these decoders work. I could add another one operation, but I don't need it. If in any moment I need it, I can just add it. So let's get down to these ones. First I'm going to show you the inputs that are coming here, and then I'm gonna come back here. Let's go there. So first we have input A and input B. Input A is all these bits, but each one is named as their bit. So this is in A0, this one will be in A1, this one will be in B1, all the way to in A7 and in B7. So these are bit 7, bit 6, 4, 3, 2, 1. I even have a name in there. So those are the inputs. So I have 8 layers of the ALU. The first layer will get input 0, the second one will get input 1, and so on. The second input that is coming into the ALU is this enables. What this enables do is that if it's false, it's going to make like every single thing is 0. Regardless of what you have here, every single thing is going to be 0. It's basically disabling input A. The same one for input B. It will just disable input B. Now, if you have, this is just enable and disable. If you have it, disabled, it's just going to make everything 0. You have it on enable, it's going to have whatever is there, and it's going to pass it through the ALU. Then you have the inverters. This just inverted. From if it's a 0, it's going to get a 1. If it's a 1, it's going to be a 0. Every single bit. This applies to, this too applies for every single bit. You cannot just invert this one. You have to invert the whole 8 bits. And so one thing that you can do is, for instance, you can, this is going to make every single one on A0. But if I put inverter A, it will make every single one 1. Because I have all zeros and then I'm inverting them, so I get 1. And invert B works exactly the same. Let me leave this to enable. And this is the increment. You just add 1 to the other, so we're gonna cover that one on the other. And this is just a shifter. It shifts to right, it shifts to left. That was right. So okay. First, we're gonna see the inputs, enablers, and inverters. That's all we're gonna see now on the analog. I'm gonna have to create a fancier entrance. So okay, right here. Input B is coming here, and input A is coming in this one. So you have in B0, which is the bit 0, because we are on the ALU 0. if we will go to this one, which are on the ALU2, you will be receiving here ALU in V2, but this one is the same all throughout the whole ALU. When this one is false, this is an AND gate. If this one is false, this gate is going to be false regardless of what you have here. If this one is true, what you have here is going to come through. And it's the same on this side, you have enabler A. So this is an AND gate. When this one is false, every single thing is false. When this is true, whatever is here is going to pass through the gate. Next one, you have XOR gates, exclusive OR. So this is just getting the output from the first gate and coming here, and you have invert B on one side and this one has invert A. The exclusive OR gate, what it does is that if this is 0, whatever you have here is going to pass through unchanged, but if this one is 1, it's going to change the output. If this is a 0, it's going to come out a 1. If this is a 1, it's going to come out a 0. So it's basically like an inverted gate that you have to put 1 for it to work, or 0 and it just doesn't work. It just passes the same output. So as I said, this is just inverting the output. In case you want to do a NOT, for instance, you want to do NOT A, you will just do an OR, and you do an OR, you invert A, and you disable B, and that way you will do like a NOT A, for instance, depending on what you want to do later. So then you have these two gates. If you see, the two outputs from A and B are coming to this gate, and the two outputs are coming to this gate. This one is an AND gate, so this is just doing an AND all the time. This is gonna be the AND or these two outputs, and this is going to be an OR or these two outputs. So regardless if you select AND or ADD, this is always going to be the output of the AND. This is going to be the AND of the two outputs. This is going to be the OR of the two outputs. But when it comes here, this is the AND with the ALU AND. This is the operation select AND. So if you don't select AND, if you select OR, for instance, this AND gate is going to be 0, regardless what you have here. If you select AND, the input that is coming here is going to pass through. These two gates use OR gates to select the output. So this, you don't have to mind these ones. And then this one here is the same. It's just an AND with the ALU OR. So when you select OR, the output from this OR gate is going to pass through. If you select anything else, this output is not going to pass through. And you can only just select one operation. So this is never going to be active at the same time. It's just either this one, or this one, which is the ADD. The ALU ADD. That's it for AND and OR. They're actually quite simple. It's just that you have the enablers on one side, you have the inverters on another side, then you have AND, OR, then you select if you want to AND, if you want to OR, and these are just OR gate to select the output, to get the output. I'm just going to do the shifter now, and that's gonna be it for this video. First, let's see the outputs that we can get with the shifter. Remember that we have NOT shift, shift left, and shift right, and all these are just names that I put it. The internal connections between all these are not named, but all the connections between one component and another component have a name for. It's a way simpler to work that way. So remember, we have NOT shift, shift left, shift right. So let's start with NOT shift. Well, first, these are the output gates. These two rows right here are just OR gates to get the output, starting from 0 all the way to 7. This is just 8 bits. This row right here is going to be the NOT shift. If you see, these are the 3 ones that are shifting. This is the only one that is complete. So let's say this is bit 7. This is just when I select NOT shift, this is an AND gate. If this one is false, it's just going to be 0. But if this one is true, it's going to pass the content of ALU rest 7. All the bits have a rest. Rest is, I made it stand for result. This is result 0, and it goes down to result 7. This is just going to let the result or result 7 pass to the ALU shifter result 7, which would, if in this case, not shifter, but I mean after the shifter. So it's really just passes the content from 7 to 7, so nothing happens. The same one, let's say this one, is rest 4, and this one is S rest 4. And this one has an input that is not connected. Okay. I forgot to find one I haven't released. So I had the rest 4 is going to go to rest 4, and let's go all the way to rest 0. That's going to go to shifter rest 0. So I said you're going from the same bit to the same bit, so you are not actually shifting anything. The only way that you're going to shift is I will pass the rest 0 to rest 1, for instance, or something like that. That's the way that I shifted. But if you pass it from 0 to 0, from 1 to 1, from 2 to 2, you're just passing the exact same output. But we have to do this to be able to select not shift. And that's it. That's not shift. That's pretty straightforward. Let's go to the other ones, which are the ones that are actually interesting. But this one is the one that is done more often. So let's start from shift left. You see this route right here? It looks like it's shifted left. We're missing one here, and it goes all the way to the left. Give me a second. Sorry about that. So when you shift left, the one on bit 0 is going to be 0, so there's nothing connected to bit 0 on this one. Bit 0 is actually going to be connected to bit 1, because you are shifting left. 0 goes to bit 1, bit 1 is going to go bit 2, bit 2 to bit 3, bit 3 to bit 4, bit 4 to bit 5, bit 5 to bit 6, bit 6 to bit 7, bit 7 just get lost in the void. So this one you have rest 0, and it's going to rest 1, to shift rest 1. And this is rest 3, and it's going to shift to rest 4. And this is rest 6, and it's going to shift to rest 7. That's it. You just basically just put the inputs on 1. You shift all the inputs here 1. So instead of putting the 0 on this one right here, you'll put it on this one. The 1 you will put it on this one, and then you connect it straight, the 0 to the 1, the 1 to the 2, the 2 to the 3. So when this shift left is true, the content of this AND gate will pass through, and it will pass the 0 to the 1, and will pass it like that. The shift right is the same, except that it goes to the right. So the bit 7 is now the one that is going to go to, is going to always be 0, and the bit 0 is the one that is going to be lost in the void. So bit 1 now goes to bit 0. Let's say bit 2 is going to go to bit 1, and bit 7 is going to go to bit 6. And this is just going to happen when ALU shift right is true. And remember that you have a decoder, so it's never going to happen that 2 of these inputs are true at the same time. There's always going to be one that is true and the other 2 are going to be false every single time. So you're either going to have it not shifted, you're either going to have shifted left, or you're going to have shift it right. That's it. And that's it, how these decoders, the AND, the OR, and the shifter works. Let's open here. Let me show you this one really quick. So you have here in bit 7 from B7 and ALU B, A7, enable A, invert B, invert A, accelerates. You have an AND between the two inputs, an OR between the two inputs. You have an AND with the ALU AND. You have an AND with the ALU OR, and these are just OR gates to get the output. That's it. So yeah, that was the video about this part. The other part is going to be covering the others. So see you on the other video. Thank you.